5 comes after the line. So guess what? We are going to, this number is equal to what? 5. So once it's equal to 5, we can add 1 to the number that comes before the line. So 4 plus 1 is equal to 5. So your answer then should be equal to 84. Okay, let me rewrite it. So don't ignore this one. So let's say equal to 84.35. Then my next question to you is, how many decimal places do you see now? 1, 2. So what we did, we expressed this number here, corrected 2 decimal places, and we got this answer. So simple. Let's go to the next one. Try this one for yourself, and let's see what the answer you got. Alright, now once again, let's write the number again. So 93.43973. You know my question, don't it? How many decimal places do you see? Let's count. 1. So I start to count what? After the decimal place. So 1, 2, 3, 4, 5, 6. But how many decimal places should we what? Write it correct to? 4 decimal places. So we're going to remove that. Let's count again. 1, 2, 3, 4, 5, 6. So where are we going to put the line? After the what? 4th digit. So 1, 2, 3, 4. So here is the 4th digit, which is 9. So 9 is the 4th digit. So guess what now? What number comes after the 4th digit? 7. And 7 is greater than 1. So we must add 1 to the 4th digit. Now, what does that become? 9 plus 1 is 10. So we carry the 0 here. We'll add 1 to this, and it becomes what? 4. So our answer then is equal to what? 93.9440. And this is 1, 2, 3, 4. So I hope now that you can replay this video once again to this point and make sure that you follow the steps as you do the try these questions. So how many places do we see? Exactly. 1, 2, 3, 4. Very good. Did you enjoy this one? I hope so. Now, I'll first try this question. Evaluate 8.45 divided by 0.7 correct to 3 decimal places. So what's the first thing you're going to do? Let me give you an hint. Work this out first, and then the answer that you get, you must write it to what? Correct to 3 decimal places. Listen carefully. Work this out first. Then the answer that you get from working this out, that's the answer, or that's the number that you're going to write correct to 3 decimal places. Did you get this for your answer? The answer is 12.071. Try this question number 2. Write 25.0347 as a decimal correct to 3 decimal places. Pause your video now and try this question. Did you get this answer? The answer is 25.035. Try this question. Give 9.7814 correct to 1. The nearest whole number, 2. 1 decimal place, and 3 decimal places. Pause your video now and try this question. To get this answer, call 3824929. Now, if you didn't get this correct, you know I'm going to tell you to try again. So call this number 3824929. Now we're looking at another concept. It's called standard form or scientific notation. Now I want to ask you to do something for me. Do you see this number? 1, 2, 3, 4, 5, 6, 0, 0, 0, 0, 1. Can you call this number? Alright, try calling this number, let me hear. Really? Okay. Anyway, if you are trying and you were able to call this number, you are 10 times better than I am. I'm unable to call this number. Now, in many different professions like an engineer and different scientific fields, you have various different size numbers. And sometimes they're very large, sometimes they're very small. Now, mathematicians have come up with a way to represent the same number using a different form. Good? And that is called a standard form. And what we'll be looking at is how do we write very big numbers like this as standard form. Okay? I want to ask you now to stay tuned for the rest of the lesson to learn how we write very big numbers like this in standard form. Thank you. Now, we're going to look at example number 1. And we are asked now to express 89,021 in standard form. The answer that you'll get is what? 8.9021 times 10 to the power of what? 4. Now stay tuned to the video clip. That will show you how we came up with this answer. Okay. Now I'm going to show you how we got our answer. So I'm going to express 89,021 in standard form. Okay, watch me carefully. Now 89021. The first thing you need to know is that we place an imaginary point right here. Can you see that? Then now we are going to count 1, 2, 3, and what? 4. And drop the point right there. And then now we have 8.9021. Then now we are going to multiply this number times 10 to the power of what? 4. How we got this 4? This 4 is the number of times I have moved this point to get here. So the point, so the 4 tells us the number of times I moved the point. Okay? So let's go again. So the 4 tells us the number of times, it's supposed to be times, the number of times I moved the point. So I moved 1, 2, 3, and what? 4. Now another thing to note is that in standard form, this number here must be less than 10. Now you can test to see if this is less than 10. How do we do that? Now, let us say that if this was 89 0.021 and you're subtracting it from 10, you're going to get a negative number. Try it on the calculator and see for yourself. You got a negative number, don't it? But guess what? If you subtract this number, 8.9021 from 10, you get a positive what? Number. Good? So therefore we are saying that this number must be less than what? 10. Right? And then now, when you multiply it by 10 to the power of 4, you should get back the number you started what? With. Is that clear? Let's start again. So, we're saying, the first thing you need to know, when you get an old number like this, old number like that, you place a point here, and then you move it 1, 2, 3, 4 between the two first what? Digits. So you move this point between the two first digits, and then now you write this answer down like that, and then you place your multiplication sign there. Is a 10 to the power of what? 4. Now this 4 indicates the number of times I move the point. And note that this number must be less than 10. Now in standard form, we're not changing the value. We just rewrite the number using exponential in what? The base 10. Good, so if you multiply this number here by 10 to the power of 4, you should get back 89,021. That's that.
Now it's time for you to try this question. Express the following number 345 in standard form. Now pause your video and try this question. Yes, the answer is 3.45 times 10 to the power of 2. Another example. Express 0.6789 in standard form. And the answer that we'll get is 6.789 times 10 to the negative 1. Stay tuned to another video clip that will show you how to do this question, or rather to show you how we came up with 6.789 times 10 to the negative 1. So listen carefully and look carefully so you may understand.
Okay, now here's another number that we are going to write in standard form. Now I want you to pay close attention to this number. Note, this number is different from the one that we have. Do you see the difference? What's the difference between this number and the one we did before? Okay, you guys have a 0 before decimal point? Okay, now once you have a 0 before decimal point, it simply means that this number is less than 1. Now, if we are going to write a number in standard form, the number must be greater than 1 but less than 10, and that is a rule. So the number must be greater than 1 but less than what? 10. Okay, now if we are going to write this number now in standard form, let us take it here, and I'm going to erase this, so I hope you write it off. I'm going to erase this part of it now. Okay, let's take the number now. 0.678 and what? 9. So how are we going to write this number in standard form? First, we're going to move the decimal point between the first two non-zero what? Digits. So 6 and 7 are the first two non-zero digits. Okay, so here are we now. So 1. Simple. So we have to move at 1 place. So therefore, write that 6.789 times what? 10 to the negative 1. Now this time we have not used positive, but we have used what? Negative. Now you might be asking why, but let us note the rules first. Once you're going to write a decimal number in standard form, automatically this number to the corner here is going to be a what? Negative number. Is that clear? So 1 indicates the number of spaces that have moved this decimal point between the first two non-zero digits. And then now we are once again, as said before, that when we multiply this number by this number, we should get back 0.6789. Now let us get to understand what this means. Now 10 to the negative 1 is equal to 1 over 10. Okay? Let's try something else. If you had 10 to the minus 2, that will be equal to 1 over 10 to the power of what? 2. Okay? Therefore, it simply means that you'll be dividing this one by 100. Because 10 to the 2 is equal to what? 100. Now, if you were to divide, let us erase this. And of course, you have a video, so you can replay it if you didn't get what I've written right here. Okay, now if you are supposed to say divide this number here, alright, divide this number 6.789 by 10, what would the answer be? Can you use the calculator? Okay, the answer will be what? 0.6789. Very good. So we still get what the same one answer that we what? Started the number that we began with at the beginning. So therefore, if you are given a decimal number to convert or to write in standard form, you first have to move the decimal point, good, from where it is, between the first what? Non-zero digit. And you realize that this number now is less than 10 and greater than 1. And then always multiply it by 10 to the power of a number. So if it's a decimal number, you're going to move it to negative what? 1. Is that clear? Very good. And that is how we write that number in standard form. So the final answer, of course, is 6.789 times 10 to the negative 1. Now you might be wondering something. You might be asking a what if question. And because I know you're asking a what if question, I'm going to answer it for you right now. Don't it? So you're asking this what if question? Alright, let us go. You might be asking, sir, what if it had 12.910? You might be asking that what if question. What if you had 12.910? Well, let me ask you a question. Is 12.910 greater than 10? Isn't it greater than 10? Yes, it is. Good. So, we have to make it less than 10. How are we going to make it less than 10? Then we're going to move this decimal point what? 1 place between the first two what? Non-zero what? Digits. And what are the first two non-zero digits? 1 and 2. So therefore, we're going to move this marker in place what? 1 time. How many times have we moved it? Once. So however, what's the answer for this? You pause the video and write down the answer for this. Alright, did you get this? 1.2910 times 10 to the what? 1. Very good. So, hope you're getting the gist of it. Alright?
Okay, here's another try this question. And of course, you know it's time for you to try this question. Express 0.00078 in standard form. And you know the routine. What's the routine? Pause the video. And guess what? Try this question. Ta-da! Did you get this answer? The answer is 7.8 times 10 to the negative 4. Now, of course, if you got this answer incorrect, students, I'm going to ask you to replay the video to this point and try the question again to see where you make your mistakes. Because guess what? When you can see where you make your mistakes, you will not make a mistake on the worksheet. So I'm going to say to particular persons, I'm going to give the initials to the student whose initial is RW. Make sure to get the try these questions correct before you go to the worksheet. The person whose is I, our names begin with the letter I. Trust me, it could be any one of you. So guess what? I want to make sure that you get to try these questions first before you go any further. We have come to the end of another video tutorial, mathematics video tutorial. We want to hope and sincere hope that this lesson was beneficial to you. And of course, it was created by yours truly, RONIQUE BERNARD, and this was recorded by Leighton Smith. Thank you for viewing another CDP Maths Lab Teaching and Learning Center production. Ta-da! Bye.
The days of Elijah, declaring the word of the Lord. And these are the days of your servant Moses, righteousness being restored. And though these are days of great trials, of famine and darkness and sword, still we are the voice in the desert, crying, prepare ye the way of the Lord.
Computation lesson number 4. The content of this lesson is ratio, proportional parts, and percentage. Pay close attention to all the demonstrations that you will now be shown. Ratio. This is our introduction. It says a certain school has 11 students to 1 teacher in a class. If there are 110 students at the school, how many are teachers, or how many teachers are there? Pause the video right now and try solving this question. Yes, pause your video here and call 382-492 for the answer. Here we have a maths class. We have one teacher and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 students. Now, we are asking you how many teachers are there if we have 110 students. Now, what is a ratio really? A ratio is just a way of comparing two or more quantities. And in this case, we're comparing the number of students to teachers. So here we have one teacher to 11 students. So the ratio of teacher to students is simply 1 to 11. Good? I'm asking you now to pay close attention to your notes. So the ratio of student to teacher here is simply 1 to 11. So if you have 11 students in one class and one teacher in one class and you have 110 students, then how many teachers would you have at that school? That's very easy. What is your answer? You could draw several pages of this. For this is one class, draw another class with 11 more students, another class with 11 more students, and see if you'd come up with the answer. Remember, call that number on your screen. Going to another example. It says 50 teachers and 110 students were to be divided to form some classes using the ratio 1 to 11. How many teachers were to be teaching each class? Once again, pause your video here and call 382-4929 for the answer. Example number 1. Express $6.30 as a ratio in its lowest term. Now here we have some Jamaican old $1 bill. We have 1, 2, 3, 4, 5, 6 $1 bill, and these bills represents the $6. And here we have 5 cents. We have 1, 2, 3, 4, 5, 6 5 cents. When you add all of them, you get what? 30 cents. What we're simply saying here is that when you get a simple, worded problem like that, you could simply draw pictures to represent the words that you are familiar with. So what they're simply asking you is to express $6.30 as a ratio in its lowest term. Guess what? Pay close to the example or the demonstration of what to do in the video clip that follows this. Okay, you're asked to express $6